Okay, we are live. So chapter 4.1, we're going to talk about exponential functions. All right, so let's say that I had a function f of x equals 3 to the x, and I said I wanted you to find f of 5. Lauren, can you help me find that? Okay, so it would be what? 3 to the 5th, which is 343, as everybody knows, right? You knew that. I knew Lauren knew that off the top of her head. She didn't need to think about that. No calculator. All right, how about f of negative 2/3? Let's click on Riley. You missed that before. You in basketball? Skiing. Skateboarding. Oh, it's not the time of year to do that. Especially now, I guess, right? Yeah. All right, so how would you do this? 3 to the negative 2/3. Now, let me ask you a question. Could you write that again without a negative exponent? You know? I'm going to tag your friend Lauren. Flip it. Okay, so what would I write? 3 to the 2/3. Okay. Now that you know we got rid of that, okay, we're going to go back to Riley. 3 to the second power is 9, so I could rewrite that as 9. And if that was the 1/3 power, how would I write that? In another way. Okay, here. What did you say? Before I don't know, what did you say? 327? Oh, no, the 1/3 power. You raised it to the 3rd power. You could write it with a radical, right? It would it be a square root? A cube root, right? So you could also write it as that was 1 over the cube root of 9. Okay? All right, and of course, if you plug yours into your calculator, you could get, as everybody knows, 0.4807. Okay? I need a camera near that off the top of his head. No, you don't need no calculator. All right, so what if I told you that I wanted you to graph f of x equals 3 to the x? Holly, what do you think? Graph that off the top of your head? It would not be a parabola. Okay, what always works when you don't know? What'd you say? But you don't know how to graph it, so what do you do?
Plug in points.
What'd you say?
Plug in some points.
Plug in some points. What are some good points, Hallie? 0 and 1 and -1 and 2. How about -2? That's good enough, okay? All right, so 3 to the 0 power is what, Hallie? Oh, thank you. 3 to the first?
30.
3 to the -1?
130.
3 squared?
9.
And 3 to the -2? 9. Okay? So, hopefully we can get away from plotting points, but we can do that for now. Okay? So I've got 0, 1. Still on camera. 1, 1, 2, 3. -1, 1/3. 2, 3, 4, 5, 6, 7, 8, 9. and -2 1/9. Okay? Am I ever going to get below 0? Okay? So I can asymptote right there. And my curve is going to look something like that. Okay? All right. Not too bad, right? What if we wanted to graph g of x equals 1/3 to the x? How would you do that, Jeffrey? Still plug in points, okay? So we'll do the same thing. What are some good points to pick?
0, 3.
3? You're going for all the hard numbers, huh? Like, I don't want to do no easy numbers.
Did you cancel out using 3 with the denominator?
No. Oh, is that why you picked 3?
Yeah.
Oh, you're going to find out that wasn't a good number, but we'll keep it. How about 1 and -1? Okay, I was hoping you'd pick the same ones that Hallie did. In fact, let's do 2 and -2 just for fun. And then we can compare better, because I have a feeling I'm going to go off the board with your numbers. Okay, 1/3 to the 0 power is 1. 1/3 to the 3rd power. It's 1/27. 1/3 to the -3 power. It's 27. Okay. 1/3 to the 1st. 1/3 to the -1. 3. 1/3 squared. 1/9. 1/3 to the -2. You're noticing a pattern there, aren't you? Okay, good. All right, well, we're going to pick the same plots because those are too hard to plot. Okay, so 0, 1, so we're going through the same spot there. 1, 1/3, -1, 3, 2, 1/9, -2, and 9. So it's going to go like this. Okay, just like that. So what do you notice about these two functions here?
You just flip.
The mirror images of each other, right? Okay. All right, so that leads to a couple of rules or notes to graph exponential functions. Okay, so exponential functions, this is true for all exponential functions. Am I off the board? Yes, I am. Okay, so those are the form f of x equals, and it can be anything besides 3. It could be a 2, a 10, whatever, a to the x power. Okay, so that's what we're talking about. So the two rules are it always goes through 0, 1. Okay? Now we're talking about unshifted things, and then we'll get into shifts in just a minute. Okay? And number 2, it always has asymptote at y equals 0. Okay? So if this was on the quiz tomorrow, the main things I'm looking for are the asymptote. I want to see the, and I don't have a special name for that. I'm just going to call it the important point.
You mean the asymptote is x is equals 0?
No, it's y equals 0.
Right.
Yeah.
Right.
I just call it the important point. Doesn't have any fancy name. Okay? So, you'll want to remember that. So if this is on the quiz tomorrow, I want to see the asymptote, I want to see the important point, and then I want to see the curve, basically. So it looks something like that. Now, if it's a 4, if your base is 4, it's going to be steeper. If your base is less than that, it's going to be shallower. So, all right. So the next question is, time for a new color, I guess. What if I had y equals 2 to the x plus 1? What does that plus 1 do to me, Andrew? Sure. Okay, good. All right, it's going to move everything up 1. So your important point is going to move up 1, and your asymptote is also going to move up 1. Okay? And so the shape will be, it'll be a little less steep than that. It's going to be something like that. Does that make sense? What if I had, time for another color. Oh, I'm out of colors. Dang it, I thought I had a black. Oh, I got rid of my black, darn it. Y equals 2 to the x plus 1. Oh, I already did that, plus 1. We're going to put that in the exponent there. Okay? What does that do, Demi?
Does it move everything down 1?
Nope. So the plus 1 here is going to move it up. The minus 1 would move it down. Since it's in the exponent, what would it do? Think of it like the parentheses. What happens when it's in the parentheses?
Oh, it would move it. It's like opposite, move it to the left.
Left. And if I had y equals 2 to the x minus 1, it would move it
Right.
right. Okay? So let's graph this one here in green. Should I get a new graph? I guess I can't draw anymore on top of that. It's getting hard to see now. All right, so 2 to the x plus 1. So Demi, tell me where my important point is going to be. It was here.
Mm-hmm.
I'm going to move it
To the left.
to the left. So now it's going to be here, right?
Yeah.
What happens to my asymptote? It also moves to the left, but that doesn't really change anything, right?
Mm-hmm.
It's still going to be here,
Mm-hmm.
okay? And it's going to look like this. Okay? So once again, see the asymptote, see the important point, which is now at negative 1, 1, okay? So we've shifted it, and the shape of the curve. Those are the main 3 things I'm looking at. Okay? How about f of x equals negative 2 to the x? What do you think that does, Michael?
It's like it'll be reflected over the x-axis.
This is going to flip over the asymptote, basically, okay, which happens to be the x-axis in this place. Okay, so my important point was here, right? Now it's where? From the other side, it's negative 1, okay? And then what?
Yeah. Plug in 1.
If I plug in, so if I do my XY table, so I got 0, negative 1. If I plug in 1, it becomes negative 2. So 1 is negative 2. Can you tell what's going on now?
Yeah.
What's happening?
Go out that way.
Yeah, so it's going to be a mirror image
Yeah.
of that. Okay? Does that make sense? Okay? Should we go crazy? Kind of like, no. Here, I'm going to pick, I think this is the craziest one, so we'll pick this one. This one is number 37 on the homework. Graph. Oh. H of x equals 2 to the x minus 4 plus 1. Okay? So let's pick on Cameron. What do you think happens in this case?
It's going to be the right 4, not 1.
Oh, I was picked on the other Cameron, but that's okay. You guys can tag team on it. So say it again.
Right 4 up 1.
Right 4. Okay, so where we started here, we're going right 1, 2, 3, 4, and up 1. Okay, so my new important point is there at 4, 2, correct? And then other Cameron,
Yes.
what should I do next?
So you're going to curve it up like that.
Where's my asymptote? Let's take care of that first.
Your asymptote is going to be at 1.
Yeah, it's going to be at y equals 1. It's going to be up 1, right? Okay, and so then it's going to look something like this. Okay, does that make sense? Are these a lot easier than the last test so far? We are going to get into logarithms and it's going to be fun.
Sorry, why is it at 1? the asymptote?
Why is the asymptote at 1? Good question. Cameron?
Because of the plus 1.
Because the plus 1 shifts both your important point up 1 and it shifts your asymptote up 1 as well. Okay? Any other questions? Okay. All right, we're now going to talk about the most common exponential function you'll use, and it's not really, well, you kind of use it in your daily life. How many of you have a loan of some sort?
Loan.
A loan, like a car loan or a house loan or anything? Okay. So the rest of you will find out about how this works, okay? The most common, this is what we call the compound interest formula. And it's going to be A of t equals p times 1 plus r over n to the nt power. Okay? So p is going to be your principal. R equals your interest rate. N equals the number of compounds per year. T equals your time in years. Okay? So, usually what will happen is you'll figure this out on the day that you get your loan, and then you'll never look at it again, but every day you'll be paying on it. Paying loan. Or this loan will be making you pay more money. All right, it does work in your favor as well. I think it is a little bit funny, the example they give. They say calculate, or actually, let's do it this way. a sum of $1,000 is invested at an interest rate of 12% per year. Find the amounts in 3 years if compounded annually, semi-annually, quarterly, monthly, and daily. Okay. So, let's see, whose turn is it? Daniel, it must be your turn. Can you help me use this formula? And we'll do the annually. And let me say one other thing before he gets started. One of the things that's most frustrating to me as a teacher is when you write down everything correctly on your paper, and then you can't plug it in your calculator. So I hope you have your calculator here today. Please, after he tells us what to write down, I want you all to practice this and see if you get the same answer, okay? So Daniel, what should I write down?
So annually is every year.
Right.
It's 12% per year.
Mm-hmm.
Is that where you put in annually?
So yeah, we're gonna go through here. What's P?
So it's the principal,
And the principal in this case is?
12%.
Nope. How much are you investing? $1,000. Okay, $1,000 times 1 plus, what's R?
It's 12%.
So how do I write that? 0.12 over number of times it compounds per year, which annually would be?
Well, it's 12% a year.
So if you're compounding it annually, how many times are you compounding?
Every year.
Yeah, which is a number of what? Once. All right. Once to the 1 times how many years? 3 years. Okay? Now, what I'd like everybody to do is go ahead and type that in your calculator, and hopefully you should get 1404.93. So let's take a few seconds and make sure that you can punch that in correctly. Have you guys remembered actually that thing? Okay, make sure you have your regular calculator tomorrow. There's no, I don't care about in class today, but make sure no cell phones tomorrow, okay? Has everybody got that? Okay. If you don't, let me know, and I will help you do that. Nathan, Allred, can you help me do it semi-annually? Do that one right. How would what would I write down?
Same thing as last time, except N,
Okay, so tell me what's right.
1,000,
1,000.
open parentheses, 1 plus, and 12 over.
Semi-annually would be
Twice a year.
twice a year. Raised to the same n, right?
Well, yeah.
2, and then how many years? 3 years. Okay? So go ahead and practice that again. Hopefully you should get 14, 18, 52. So what do you notice about the difference between annually and semi-annually? What's the difference? What do you notice, Nathan? How much more do you get semi-annually? About $14, right? It's not bad, right? So would you prefer annually or semi-annually? If you're investing, you want semi. If you're getting the loan, what you want? Annually. Which one do you think the bank uses?
Daily.
Daily, that's actually correct. Okay? They want their money. Let's see how much that goes up. Okay, how about Eunice? Can you tell me how to do it quarterly?
You just said, do the same thing with just before, just said
Okay, so tell me what direct.
1,000,
1,000?
then 1 plus, 0.12 over 4 times.
Okay. And hopefully, if you punch it in your calculator correctly, you should get 1425.76. So the difference between those two numbers is approximately how much? About $7, okay? And then monthly, Connor, can you help me do that?
Yeah, would it just be 12?
Yep,
So 1,000,
1,000,
parentheses 1 plus 0.12 over 12, parentheses 12 times 3.
okay? And that should work out to be 1430.77. And then finally, Zach, can you help me do daily?
1,000. 12. 365. 365 times 3.
Okay, so this will be the one that you're most likely to mess up on your calculator, but hopefully you get 1433.24. Okay, so if you're investing, you like the more frequent compounds. If you're loaning, the bank likes it. Okay? All right, well, I think that'll do it. So, if you didn't get any M&Ms or Jolly Ranchers, go pick some up. Quiz tomorrow is going to be on 4.1. We'll see you all tomorrow. You will probably need a calculator for the quiz, especially if I give you one of these, unless you want to do that in your head. Okay? See you all tomorrow.